My name is Dan Szumski. The title of my presentation is The Theorist's Role in Unraveling Cold Fusion Physics. If we're to unravel the cold fusion process, we need to comprehend it at a much more fundamental level than calorimetry. Consider the possibility that cold fusion might consist of three sub-processes. The tertiary process is excess heat generation. A secondary process is nuclear transmutations, but the primary process is energy accumulation and storage. In this presentation, we develop a methodology for measuring the secondary process, and in particular, observing the time history of individual nuclear transmutation events. The experimental hypothesis is LANP theory predicts the order in which specific nuclear transmutations occur in a thin-film nickel electrode. The theorist's view of nuclear transmutations differs from the experimentalist's. While the experimentalist focuses on measuring initial electrode composition and the transmutation end products, the theorist is more interested in the story of how the process develops from natural laws. The least action nuclear process theory is used to develop an experimental hypothesis that specifies the time sequence of nuclear transmutations in a thin-film nickel electrode made from 99.999% fine nickel 58 and a single mono-isotopic element impurity such as 99.99% fine scandium 45. The theory provides energetic calculations for the initial fusion transmutation, followed by a decay process along the path having the smallest energy change. The experiment is designed to measure the isotope composition of a thin-film, nickel-coated glass bead electrode at intervals determined in pre-experimental trials. The measurements are then compared to LANP model calculations that were prepared during the experiment's planning phase. An example is shown here. You will note that the theoretical calculations specify the nuclear reactions in order of increasing fusion energy requirement and break out individual components of the energy change. Only two components of that change are shown here. Thank you very much.